Okay, I will start with the recording. All right, good afternoon, grade 9/1. Good afternoon, students. All right, can anyone hear me? Good afternoon.
Afternoon, teacher.
Oh, yes, good afternoon. All right, thank you. And for today, we will continue all about probability. Anyway, that is a lighter topic. Okay, so the last meeting that we had, we discussed about events and outcomes. All right. And for today, we will discuss probability and also outcomes of independent events. All right. So let me start with this slide. All right. So here we go. All about probability. All right. Okay, so one more time, let me share it again. So we are 7. Otto, Pang, Ton, Kaimuk, Kung Fu, and Pawan. All right. Okay, so there we go. Probability. Now, we ask ourselves, what is really probability? Okay, Otto, please read what is the definition of probability. All right, Otto, please unmute and read. What is probability? Otto? All right, Pawan, okay, please read, Pawan. Probability is a measure.
Okay. Probability is a measure on how likely something is going to happen.
All right, so it is a measure. So that means it will be like telling us how something is going to happen. Is it happening? Is it impossible? Is it 50-50 chance? Is it 100% possible? So that is probability. Now, if you are asked, okay, if you are asked, for example, will it rain this afternoon? All right. Now, if you look at the skies and the sky is cloudy, then there is a great possibility or probability that it will rain. Okay. So that means it is a measure on how things would going to happen or what will be the outcome or the result of the thing. So the higher the probability, the more likely something is going to happen. Or if the possibility or the probability is lower, then there is also a lower chance that the thing or the event will happen. So it goes vice versa. All right. So, for example, we put that one into a probability scale. Okay. So you have there on your screen a probability scale if we use it from 0% or being impossible to 100%, or that is where the possibility is true. All right. Now, for example, you are asked the sun, okay, the statement or the event, the sun will rise on the west. Okay. The sun, again, the sun will rise on the west. If you are to put it in a probability scale, is it impossible? Is it less likely to happen? Is it 50% chance? Is it more likely to happen or 100% to happen? Again, please unmute. Okay, Kaimuk. All right, please unmute. The event is the sun will rise on the west. Okay, use the probability scale. What is the percentage? Kaimuk?
Yes.
Okay, the sun will rise in the west. What is it? Is it 0%, 50%, or 100% to happen? Yes, Kemu?
0%.
0% or impossible, because we know that the sun will rise in the west. Okay, so that means we can use the probability scale in order to tell how something is going to happen. Okay, so for example, you are asked, okay, and you buy one ticket for lottery. Okay, let us say you buy one ticket for lottery. So what is the chance of winning the lottery? So you have, it is not 0%, but you have a very, 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 very small chance of winning. So less likely to happen. Okay, less likely to happen. Very small chance. But it is not impossible, but it has a very small chance. Okay, so that is probability scale. Now, example, you have this coin. All right, you have the head and the tail. If I flip this coin over, all right, if I flip this one over, what is the probability that it will be a head? Dean? Again, if I flip this coin over, what is the probability that it is a head? Yes, Dean.
Yes.
It is. If you use percentage, what would that be?
50.
Again, it's staggering. Again, what did you say?
50%.
50% or even chance. Why 50%? Because both you have only two chances. So 50-50. 50% could be a head, 50% could be a tail. Okay? So you have an even chance. Different from impossible, different from less likely to happen, and different from 100%. Okay? So that means you have a 50-50 chance of having a tail or a head. All right? So it is, okay, that is the use of that probability scale that we are mentioning. All right? So again, take note that probability is the measure. So we can use impossible, less likely to happen, 50% or even chance, more likely to happen, or 100%, which is possible. Okay. Now, if I say I will die, okay, so the event is I will die. That is 100% to happen. That is possible, but we don't know when. Okay, but the situation there is I will die. All right, so it is 100% to happen to us, but we just don't know when. All right, so that is in putting it in a probability scale. All right. Now, if we are to get the probability of something, all right? For example, if I toss a coin twice, I see heads and a tails in either order. So what does it mean? So if you toss a coin twice, take note that the probability is the matching of the outcomes over the total possible outcomes. Now, this coin, if I toss this one, so there are only two possible outcomes. All right, it can be a head or a tail. Or if a dice, all right, you know what is a dice with a dot or a number 1, 2, 3, 4, 5, 6. If I toss a dice, then the total possible outcomes is 6 because we can get either 1 out of 6, 2, okay, 2 dots out of 6, 3 dots out of 6, 4 dots, 5 dots, 6 dots out of 6 possible outcomes. So in this situation, if you toss a coin twice, so that means you multiply it 2 times. So 1/2 times 2 is you get 2 over 4. So the same, if we reduce to lowest term, it is still 1/2 or 50% chance. Okay? If you toss a coin 3 times and you see a 2 head and a tail, so what is then the probability? All right, so take note, we multiply the times. So you can have 3 over 8, or you can throw a coin, follow the tails, or you can have another. Okay, now this one, how can we find the probability of an event? For example, a dice. We know that the probability of each outcome is 1 over 6. So you get 1, the chance is 1 over 6. You get 2, the chance is 1 over 6. 3, 1 over 6. So 4, 5, and 6. All of that, you have a chance of 1 over 6. Each number, 1. Okay, so we call that one as the theoretical probability because we know what is the underlying or the probability of an event. Example, you roll the dice. So probability of getting number 1 is you have a chance that is 1 over the possible outcomes 6. Same is true if you are to toss to get the probability of getting number 2. It is still the same, 1 over 6. You have 3, 4, 5, 6 dots. Still the same probability, 1 over 6. So we know already the possible outcome. All right, it could be 1, 1 over 6, and 2, 1 over 6, 3, 4, 5, and 6. So the chance is we can get it 1 out of the 6 possible outcomes. All right. So if we roll it twice, all right, what does it mean when we roll it twice? For example, the dice, you rolled it twice. So meaning you multiply this one by 2 because we rolled it twice. So therefore, the chance that you can get 1 when you rolled it twice will be 2 over 12. All right. So just the same, you have 1 over 6 chances of taking out 1, even if you roll it twice. All right. So that is what we mean when we say probability. We can put it on a probability scale, or we can calculate the probability by using the number over the possible outcomes or result. All right. Okay. So here, in addition, how can we find the probability of an event? Okay, so it is by multiplying the number of times and its probability. So that is why if probability is 1 over 6 and you rolled it twice, or let us say you rolled it 5 times, then multiply the probability 1 over 6 times 5, and then you will get the possible outcomes of the event. Okay, so that was the first topic on probability. We can use probability scale, or we can calculate the possible outcome using the formula that we just mentioned. Probability of getting 1 in a dice, for example, is 1 over 6. probability of getting head in a toss of coin is 1/2. So we can tell the probability underlying, okay, of that event. Okay. Now, for example, we use the words. Okay, let us say this word, orange. Okay, O-R-A-N, all right, G-E. Okay, from the word orange. So how many letters? 1, 2, 3, 4, 5, 6. Okay. Now, if you are asked, what is the probability of getting letter A? All right. So probability of getting letter A, all right, is letter A only 1. So 1/6. All right. Since letter A is only 1 and the total is 1, 2, 3, 4, 5, 6. So the total letters of the word orange is 6. So 1/6. What is the chance that you will get letter G? So you have also one letter G. So therefore, the probability is 1/6. All right. Ton. All right, Ton, please unmute. Ton. What is the probability of getting vowel letters? All right, Ton. What is the probability of getting vowel letters? You know that one in your English, right? What are vowel letters? A, E, I, O, U. So those are vowel letters. All right, Ton, what is the chance or probability of getting vowel? Yes, Ton? What is the chance of getting the vowel letters? Is there a problem in your... Yes, Ton, all right. All right, I'll go back to you later, Ton. Okay, Kaimuk. All right, what is the chance of getting vowel letters? Kaimuk.
1/6.
1/6. Okay, so you answered 1/6. Fung Fu. All right, Fung Fu. What is the chance of getting vowel letters? Fung Fu. Fung Fu, are you there? All right, so we will go. Now take note, vowel letters you have there, A, E, I, O, U. So how many vowel letters are there in the word orange? You have 1, 2, and 3. So therefore, the probability of getting vowel letters is 3/6. All right, 3/6, or it is equivalent to 1/2. All right, reduced to lowest term, 3/6 is equivalent to 1/2. So that is the probability of getting vowel letters. All right, what is then the probability of getting consonant letters? Okay, so what is the probability of getting consonants? All right, Otto. Otto, please. What is the probability of getting consonant letters? Yes, Otto? How many consonant letters are there?
6.
Is that 6 consonants? If O, A, and E is vowel, are vowels, what are consonants? We have letter R, N, and G. So therefore, probability is 3. All right, probability is 3 out of 6, or that is the same with the vowel. That is equivalent to 1/2. Since there are 3 vowels in that orange, and there are also 3 consonants in that word orange. Okay, so that is probability. All right. So let us now go to probability of, all right, independent events. Okay, independent events, meaning separate, meaning not the same event because they are independent. Example, when a fair coin is thrown, what is the probability of getting head? Okay, so we discussed already that one. That is 1/2. If 3, then we have there 1/8. And okay, so next, if we are to get the probability of independent events, then it does not affect the other. So independent, that means it cannot affect the other, or it is separate from the other event. Okay, take a look on this example. You have here coin toss, which is event 1. Okay, and we have also dice roll, which is event 2. So they are independent from each other. Okay, it does not depend on one. So they are independent. Now, if we do the 2 events, what will be the combined outcomes or result? All right. So when you toss a coin, it can be a head or a tail. So that is the first event. Now the second event, if you roll a dice, then you can either get number 1, 2, 3, 4, 5, or 6. So that is why head, the possibility you can have a head and 1. All right, head and 1. Or you can have a head and 2, or head and 3. So that is why we have these combined outcomes. So if you are getting a head and a 1, so that is why you have H and 1, head and 1, head and 2. So head and 2. You have 3 and 4, all right, 5, head and 6. So these are the possible outcomes of the 2 events. All right. When you toss the coin and you get the tail, it will be the same with having the first. So you can have a tail and a 1. You can have a tail and a 2. You can have a tail and a 3, a 4, a 5, a 6. So therefore, in the possible or combined outcomes, you get the tail and a 1, tail and a 2, tail and a 3, 4, 5, and 6. Okay? So those are the possibility. All right? So how we discuss it more? Okay, few moments, it suddenly stopped. Okay. All right, one moment, few moments. Okay. Okay, one more time, let me share it again. Okay, so there you go. And share. All right. So next. Okay, let us try to identify whether the following are dependent or independent event. Take note, independent means separate. and is not dependent on the other. For example, okay, Pawan, please unmute. Throwing a heads on the first flip, and event 2, throwing a heads on the second flip. So is that dependent or independent?
Dependent.
Take note. First flip and second flip. So they are
Independent.
okay. So they are independent event because the first throw, it will not affect if you throw another one. So it will not affect. Now, what about it rains tomorrow and it rains the day after? All right, Pang, is it a yes or a no? Independent or not? Pang? Hello? All right. P. Okay, P. Is that yes or no? It rains tomorrow. It rains after the day after. Independent event or not? Okay, so that is not independent. Okay, because sometimes rain will follow right after rain. Okay, so that is dependent event. Now, that I will choose maths at level A level, or the second event that I will choose physics at A level. What is that one? Otto, is that dependent or independent? Otto, dependent or independent?
Independent.
Okay, so that is not okay. So it is a no, because again, you will not have, or you have nothing to choose, because it will not depend on you, but it depends on the school. Okay, so that is not independent. And lastly, have a garden at home and being called Bart. So it's very obvious they are independent events. So you have a garden at home, it is nothing to do when you are called Bart. Okay, so they are independent events. All right. Okay, so we have done that 3 diagrams. Okay, so that is how to illustrate and demonstrate the probability of combined events. Just like, for example, here, this is a 3 diagram. The question is, what is the probability of getting orange twice? All right, so you have here orange twice. So you have there one orange and you have also another orange. And take note, the probability is 1/5 and the second is 1/5. So therefore, the probability is 1/5 times 1/5, which is equals to 1/25. Second, seeing different colors, so different. So you have 1/5, you have 4/5, 1/5, and 4/5. So therefore, you are having a chance of 8/25. Okay? Or the chance of seeing the same color twice. So the chance there is 17/25. Take note, 1 there would mean 25, because that is the possible chances. So that is 25/25, or 1 minus 8/25. So you get 17/25. So that means we multiply event 1, the probability, event 1 times event 2 times event 3, or how many events. Okay, so the probability again is we multiply the independent events. Event 1 times event 2. Same is true with the coin cost times the rolling of dice. So that is why we have a head and 1 ahead and to, because we multiply it so that we can get the probability. Okay, so again, multiply probability of independent events, multiply event 1 times event 2 or event 3, or how many events given the situation. All right. So, okay, that will be all. And that will be so much for the discussion. We will go to our workbook. Okay, so we have 5 minutes left. So I think we can answer. We have to answer only 2 pages, page 135 and 136. Exercise 11.3. All right. So exercise 11.3. Okay. All right. So page 135. Those who have books, please write in advance. Those who have not, then you can do it in a paper and then do it in the book once we are getting into on-site. So page 135. And the date of today is Friday 21 January 2022. Okay. Exercise 11.3, number 1. Draw a tree diagram to show all the possible outcomes from the following independent events. So letter A, you have there a dice rolled followed by toss coin. So the first is you have here a dice, and the second event is toss coin. Okay, so this is the second event, toss coin. And then the combined outcomes. All right, so please follow. This is number 1, letter A, so that you can answer the next letter. So this is the combined. Okay. So we know that a dice have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6. Now, in a coin, we can have a tail or a head. So we can have this one, head and tail. So you have there 1 and a head, 2 and a head. This is the tree diagram. 4 and a head, 5, 6 and a head. Now, if we are to get the combined outcomes, 1 and head, all right, 2 and head, all right, 3 and head, you have there 4, 5, 6 and a head. Okay, so those are the independent events that we mean. So we multiply it together, so meaning we combine. Or you can have 1, 2, 3, 4, all right, 5, 6, and a tail for the second event. So that is why you can have 1 tail, 2 and a tail, 3 and a tail, 4 and a tail, 5 and a tail, and 6 and a tail. So that is, and then the combined result, so you have 1 and tail, combine, 2 and tail, 3 and tail, all right, 4 and tail, 5, and then 6 and a tail. So this is the tree diagram for number 1, letter A. So that is the answer. All right, so we have a 1 minute and 30 seconds. Then you can answer letter B and C and number 2, A, B, C. Okay, only page 135 and 136 of the book. Okay. So that is the answer for number 1, letter A, and follow letter B and C, and then number 2. All right, so we don't have much time. And okay, are you finished copying this one? All right, thank you so much for your attendance today, and you take care always. All right, we will wait for some information whether we go to the school next week or not. Or have you have any information next week? Do we go to school or no? Taimuk, Dean, do you have
No,
any
no.
go to school next week or not? Taimuk?
No.
No? Okay, there is information already not to go? Pawan?